Okay, so now we're talking about angles changing. So let's make sure we set this problem up. So we've got this 10-foot ladder. I keep doing the 10-foot ladder. Maybe I'll change it next time. Okay, so it leans against a wall. The top of the ladder slides down, so it's going down. So if I make that a y, I know I'm going to make dy over dt equal to -2. So this is asking a different kind of question. How fast is the angle between the top of the ladder and the wall? So that's talking about that angle there. How fast is that changing? So that's find d theta over dt. And so let's look about what the when information. When the bottom of the ladder, when this is 4. So when x equal 4. I'm going to put a circle around that. Remember, we don't use that until after the derivative. All right, so now let's think about what do we need to have in our equation. We need to have y and theta, right? Because I'm trying to find d theta dt. I've given dy dt, and I want to use the 10. So big thing here, don't use x in your equation, because I don't have information. I'll use it when I have the when, but I'm not going to use it in my equation. So in my equation, if this is the angle, can you see that this is cosine of theta is equal to adjacent over hypotenuse? Okay, I've got an equation. Let's take the derivative with respect to t on both sides. Remember, you got to say d theta over dt. This is just like the number 1/10 times y. So that's dy over dt. So now let's see what I've got to plug in. So dy over dt is -2. So I'm just going to continue it down here. So -2 times a 1/10. D theta over dt, well, that's what I'm trying to find. So that's okay to have there. Oh, I don't know what sine is. Let's put in our 4, and I'm just going to put it in the picture because sometimes that helps better. So here's x, here's my theta, there's my y. Hey, wait a minute. If that's my angle, don't I know that sine of theta is opposite over hypotenuse? Will you look at that? I get to take out sine of theta and put in, and I'll just simplify it, 2 over 5. And so then I'm going to multiply both sides. So let's see, d theta over dt. Let me go slow so I don't make a mistake. So this would give me a -1/5 times a -5 over 2. So that gives me a +1/2. Okay, let's make sure that makes sense. Is it true, you think, that that angle will be getting bigger as the ladder slides out? Yes. So d theta over dt is 1/2. All right, so that's that kind of problem. Let's look at this conveyor belt. We did one like this the other day, but these are hard. So I want to go over it again. So we know that the volume, let's come back, the volume of this cone, right, it's dropping into like this, 1/3 pi r squared h. So that's, you have to know that equation. Okay, so there's 15 cubic meters falling down. So that's our dv over dt. And let's see, the height of the pile is 1/4 the base of the diameter. Okay, I know I'm going to need that. So height of the pile is 1/4 the base of the diameter. And then let's go find, what is it we're trying to find? Find the when the height is changing. So find dh over dt. And then when h is equal to 8. So save that till after the derivative. So I'm going to take this and I'm going to replace d with 2r. And then that gives me 1/2 r. So 2h is r. Then I'm going to take this and I'm going to substitute it in. So let me come again over here. So volume is 1/3 pi 2h squared times an h, right? So replace r with 2h, and I'm going to square it before I take the derivative. So that gives me 4h squared times an h. Now, finally, after I simplify it, I want to take the derivative. So dv over dt, I'm going to carry this ugly 4/3 pi along, 3h squared times dh over dt. And then I'm going to cancel those 3's, and I'm going to see what I can plug in. I see that I can put in 15 on this side, and I get 4 pi, and I'm going to plug in h is 8, and then I'm solving for dh over dt. Okay, so then I just take 15 divided by 4 pi times 64. There it is. So the height is a positive amount growing.